Homer Simpson says DoH in an image on a slide.
All right, here we go. Welcome everyone to DoH, how to implement DNS over HTTPS on Windows Server 2025 with Jay Schultz. I am David Berg. I am your moderator today. During the session, we will have some time for Q&A, but we'll be holding most of that to the end. So if you do have questions that come up during the presentation, feel free to just put those in the chat and we'll make sure that those are answered. A little bit about Jay. Jay is the system engineer for the Aquatic Sciences Center. And he's been at UW-Madison for 12 plus years, which is awesome. Jay has done a couple of presentations throughout the IT Professionals Conference through the history of it. And he's always a great person to talk to, and I'm looking forward to hearing his thoughts on this topic today. So without further ado, let's turn the time over to Jay.
Jay appears.
All right. Thank you, David. All right. Camera seems to be kicking in now, so that's good. So this is going to be a overview on how to implement DNS over HTTPS or DoH on Windows Server 2025. And I'll kind of give a little bit of background on this. It's a pretty niche DNS topic. I'll admit that right off the bat. And the reason I got kind of interested in this is because a question came up during some of the campus protests about privacy, security, and people on campus having, their website traffic looked up and searched and investigated. So I thought, well, I'm sure there's a solution out there, and this is one of a few that I came across, and it seems to be the one that's kind of the most mature and the one that Windows 2025 and Microsoft are going to be supporting here in preview for a little while. And so I decided to give it a look through and kind of give you guys a quick report on what I found. So without further ado, we'll just kind of get right into it here. And then if you guys are okay, I'm just going to stop my video and then go right through the presentation here. All right. So let's see. So basically what we're going to look at here is how to do DNS lookups without compromising security and privacy. And we're focusing mostly on completely on Windows DNS, not on enterprise IPAM solution like we use, like Infoblox. And I'm sure there's a way to do it there too. I just did not get into that.
Flowcharts.
So here's how DNS typically works, just high-level overview for those of you who might not be aware. You got a browser, you type in a URL, and you get a website back. As you know, the website is determined by an IP address. So that IP address is stored in our wonderful system called DNS, which we like to call domain name services, or basically the white pages for the internet. And so basically what we do is we get an IP address from that DNS server, which says, oh, you want to go to CNN? That's 1.2.3.4. And the browser takes that and uses that to get to CNN or whatever website you look up.
Chart expands.
And then this kind of goes a little bit more involved. If the first DNS server doesn't know, it can go up to other servers like the root servers if it needs to, forwarders, conditional forwarders. You have authoritative name servers. So we're getting a little bit into the weeds there, but essentially DNS can focus, point to other DNS servers, and the authoritative name servers, the end all be all of the domain name records for that particular domain. So what is DNS over HTTPS? Basically what it is it's DNS over HTTPS protocol using port 443, and all the queries appear as regular web traffic. So you can't tell a DNS query apart from just regular SSL traffic. It's part of the IETF RFC 8484, which was first defined about 8 years ago, and it's still very much in a preview, sort of being written type thing. It uses a MIME type of application DNS message, and then it's obviously very much still a work in progress. So like the server 2025 DNS over HTTPS is in a preview state, so it's not ready for production yet.
An image of white computer text over black appears on the next slide.
So as kind of said, it's a protocol that provides the secure method of looking up domains. Typically, DNS queries are transmitted on port 53 over the clear. DoH transmits the DNS queries as standard HTTPS traffic, which masks both the content and nature. So not only does it not, can you not see that it's DNS traffic, you can also not see the packet content itself. This image right here is just a quick Wireshark grab of a random port 53 DNS lookup from my machine to get the IP address for UW-Madison.app.box.com. So you can see there very clearly what I'm looking up and what address was returned, and it's very much a standard run-of-the-mill DNS packet and query.
User datagram protocol.
There are some other secure transport protocols out there for DNS. Some of these include DOT, which is DNS over TLS, and DOQ, which is DNS over QUIC or QUIC. DNS over TLS acts much as the same way as DoH does. However, it does not hide its nature as DNS-based traffic. So it still uses port 53, and it is still DNS traffic. It's just the packet is encrypted itself. DNS over QUIC or QUIC is a transport layer network protocol that does away mostly with TCP connections and uses with basically multiplexed UDP connections for better performance. It works a lot like DoH, but completely eliminates the HTTP stack of it and uses port 853. And you can sometimes see this if you use like Cloudflare or another like enterprise DNS resolver. They will sometimes say like, QUIC protocol handshake error or something like that. If you refresh a page too many times, you'll get to see that because some of the UDP packets will get dropped. But you can see that sometimes it's a very kind of niche technology used by like Cloudflare, Google, and other enterprisey type places. It has a 0 round trip handshake, so there's no back and forth. It's visible as DNS traffic on UDP port 853 and can be very easily blocked and identified.
Configuring DoH.
So kind of getting into the weeds here a little bit with DoH and Server 2025. Here are some of the prerequisites. Just kind of go through that. So you need Server 2025 with latest Windows updates installed. And then it's basically configure and install and verify that the DNS server's working as it should on, plain old port 53. And then to enable the feature, you actually have to download these two preview KBs, and you have to install them in order.
Character strings.
And essentially what you do is install these two quick little MSI things, reboot.
File location.
And it'll bring up these group policy templates for each one of those. I'll kind of show you what they look like here. So it's basically just a very generic feature preview group policy setting. It says enable the 26.01.26.22451 feature.
State enabled.
And then enable the 26.01.26.23.001 feature. I did not drill down to see like what registry settings or hacks they enabled. I have a pretty good idea of what it did is allow, I'll show you kind of in a minute, but it kind of allows us to attach SSL to port 80 or 8 to port 53 rather, in an unconventional way that wasn't kind of designed to do.
Command text appears.
So here we've got, pretty standard PowerShell command to open the firewall to allow SSL traffic. And then after that, we install DNS services and management tools on that, and then import the certificate into the local computer store.
Certificate.
So if you've ever installed like a client certificate on a domain joined workstation or server, same process. You just go into the certificate manager and then request a certificate. The caveat is you want to make sure that it has the server authentication key usage included with it, which the AD Active Directory one does by default.
Certificate enrollment.
And then what you're going to do is bind the certificate to the server port. So what we have to do is a little bit of PowerShell CLI work, and then basically just create a new globally unique identifier. And then what we're going to do is assign that certificate to a variable, and then bind it to the port 443 using that certificate, and then with that GUID attached to it.
Code text.
And so what all this basically does is adds our certificate that we just got from Active Directory, attaches it to port 443, identifies it by the certificate hash, and then gives it the application ID of that random global unique ID that we generated before.
Success message appears.
And then you'll see that your SSL certificate was successfully added. And then after that point, we just have to open the firewall to allow traffic. So DNS over HTTPS, local port 443 allow. That's of course if you don't have web traffic coming in on this already, but I would say running a web server on a DNS server is asking for trouble in a variety of ways, so I would not recommend doing that.
PowerShell.
Anyway, we've got our PowerShell output here. You can see that we now have DNS over HTTPS rule enabled.
Command text.
And then what we're going to do is just go ahead and enable the actual feature. So what we do is run this PowerShell command, and I think this is what one of those preview KB things installs, is this PowerShell command to enable this DoH. And in my case, the server I was using was ASC-DOH-test-AS. And so here you can see that what it does is basically attaches this URI template, and I'll show you where that comes into play in a second, to this URL that points to my server. So we're pointing it to port 443, and then the endpoint here is DNS-query. And then from there, we just restart the DNS service, and then basically verify that the protocol is enabled, and then it'll give you the URI template right there again.
Output text.
So that, then we configure our client to use DNS over HTTPS. So you could do add by server address. In my case, that was my IP, and then my template address is right there.
Server address.
And then you'll see the output of the command is auto upgrade to HTTPS is true.
Settings menu.
And then if you look at it from the client end, if you're more of the GUI person, you can see here that we have preferred DNS set to 144.92.44.141, which points to my test DOH server. And that template is that URI that we generated earlier. Andre, I'll get to your question in just a second, but good question. Some caveats and concerns. Some of these I kind of went through. DNS over HTTPS is still in preview, not quite ready for production use yet. most operating systems and web browsers support DNS over HTTPS, but that's to double check your compatibility if you were to push this out in an enterprisey or large scale environment. And then one problem is that it becomes impossible to filter or block DNS requests to combat malicious sites, malware, etc. Because if everybody's using DNS or HTTPS, you can't filter that because it's all just HTTPS traffic. You'd have to block all outgoing and incoming HTTPS traffic, or run it through a proxy that maybe could find a way to do it then. But let's just say impossible to difficult to filter block DNS requests. And then lastly, it's always DNS. I'll just be honest, anytime you're messing with DNS is just asking for a fun time because, yeah, as our question at the beginning here kind of pointed at, DNS can be responsible for a whole host of issues and problems and things like that. So it just adds another complexity to an already, let's just say, easily broken system. So yeah, it's just one of those things to kind of keep in the back of your mind if you were going to do this. Andre had a question in the chat about how long the cert would be valid for. Active Directory issues certs for 365 days. And those are trusted by the Active Directory domain. So basically any machine that is joined to the domain is going to trust that. So as long as your DNS server is got a valid certificate from any sort of certificate authority, then it'll be valid for as long as their certificate is valid. You could probably do this with Let's Encrypt. To be honest, I just ran out of time and didn't get into that part of it, but that's something that I would definitely look at if I was going to do this like enterprise scale.
Text. J. Schultz, System Engineer 4, J at aqua.wisc.edu.
You don't have to regenerate the AD certificate. There's a task, I believe, that will check certificates every day, I believe. If I go into task schedule, I could tell you for sure. But I know it does check for certificates that are going to be expiring soon and will renew them for you.
The slide with J's info says, questions? It lists his place of work as Aquatic Sciences Center. Bottom slide text says, IT Professionals Conference 2026. DNS over HTTPS.
If anyone has any other questions, feel free to put those in the chat, or you can unmute yourself and ask them vocally. So either way works for us.
David reappears in a tile in the upper right. J replaces David in the tile.
If anybody wanted to see a Wireshark capture of DNS over HTTPS, just mash on your keyboard a bunch, and that's basically what it looks like. Quick aside, anybody here run into issues with Firefox and DNS over HTTPS being enabled by default? I know I had to push out a group policy to disable it because a lot of people were getting website timeouts.
Oh, man.
I didn't know it was enabled by default, and it's supposed to fall back, but it wasn't for some reason. I don't know.
Yeah.
Just another adventure with DNS.
Just another adventure. Well, I think if there's no questions or thoughts, we could call it a little bit early. And so thank you everyone for coming to today's presentation. Thank you, Jay, for sharing all of this with us. It was very informative and learned some new things today. So thank you so much. And I hope everybody has a fantastic rest of your Friday. And thank you for attending the IT Professionals Conference this year. Have a good one, everyone.
Thank you, everybody.
J-Waves.